Considering the uses to which this model will be put, it's difficult not to be tremendously impressed. This is, in fact, an unique engineering tool for proving the future, or possibly proving a number of potential futures. It's also possibly one of the most imaginative and far-reaching projects ever authorized by our Congress.
The model was built to study this proposal to put a couple of dams on San Francisco Bay, which is the Reber plan. The plan was actually, it got a lot of momentum. It got very close to implementing the plan, but no comprehensive studies had been done. So in 1956, Congress appropriated funds. They told the U.S. Army Corps of Engineers, build this model, study the plan. So in 1956, they started construction of the model, studied the plan, and concluded that a couple of dams on San Francisco Bay would be an environmental disaster. So this is the model that saved the bay from being dammed and destroyed, literally and figuratively. And once it was up and running, the Army Corps of Engineers continued to operate this as a research facility for about 40 years. And everything that could affect the bay and the estuary was studied on the model. So everything from salt intrusion up into the delta, what happens when you dredge, change the velocity of the water, what happens when there's shoreline development, droughts, floods, water diversions, oil spills, all these things were studied on the model, and it was active as a research facility up until the year 2000. And by that time, we had super fast little computers you could hold in your hand, so they didn't need a warehouse full of people running around doing it all manually. So the model was retired as a research tool, and this transitioned into an educational facility. So now it is a good place to get an overview of water resource issues in the state of California, since that's a hot topic. And since our little watershed here is where 40% of the state of California's water comes through, but before it even makes it down here to Richardson Bay, more than half that water has already been diverted. So how do you balance human, agrarian, industrial, wildlife needs, uses for water? It's not renewable, it's all that we've got, so how are we going to wisely manage it?
Congress in 1950 authorized the survey leading to the construction of the San Francisco Bay model. How precise, the viewer might ask, is this model? Since it's inconceivable that the Army engineers could have surveyed every contour, every depth, and every shoal in the San Francisco Bay area in 2 years' time. Thousands of aerial photographs were taken of the area, and hundreds of blueprints were drawn to set down each detail that could be scientifically accumulated. And over 100 years ago, topographers and engineers of the U.S. Coast Guard and Geodetic Survey began exploring and defining the phenomena that is San Francisco Bay. These maps were studied and evaluated in conjunction with the thousands of maps and charts accumulated during the intervening century. With this graphic history at hand, the model was erected under the most rigidly controlled specifications to a horizontal scale of 1 foot to 1,000 feet and a vertical scale of 1 foot to 100 feet. The model itself consists of 168 precast and reinforced 12 by 12 foot concrete blocks weighing 5 tons each. These blocks, supported at the corners by leveling screws embedded in the concrete, help align the model when the settlement of the warehouse floor in which the model is housed occurs, and permits proper adjustment of the model floor to correspond to the elevations of the bay. These corner bolts, in addition, supply a resiliency that protects the model from earthquakes. Reinforcing steel was mounted in forms designed to duplicate the topography of the bay. And after concrete pouring, a layer of mortar was added, shaped to follow the rises and the falls of the bay floor. Vertical copper strips were next inserted to retard the current velocities. And then a crane was used to lift the slabs into place, just as in a gigantic jigsaw puzzle. And the blocks were sealed together with bituminous jointing material, duplicating thus in 2 years' time a project which took nature eons and eons to create. Now that the model was erected, the problem of accumulating information on the behavior of bay tides, the salt content in various areas, and the degree of sedimentation had to be confronted and resolved. So on the morning of September 21st, 1956, at the time of the autumnal equinox, 15 small craft, laden with assorted scientific detecting and measuring instruments, left Sausalito, beginning one of the most important nautical safaris in the history of the San Francisco Bay. 11 of these boats took up predetermined positions in the Greater Bay Area, Alviso, Palo Alto, San Pablo Bay, to record conditions during the 48-hour period of the mean tide, throughout 550 square miles that comprise the area under study. The remaining boats served as monitors, troubleshooters, communication craft. Crew members probed the cold midnight waters with elaborate instruments to gather data on the current, salinity, and sedimentation. Meters that measured the velocity of the currents at varying depths recorded that and other desired information at half-hour intervals in the most comprehensive physical examination of the bay in its entire history. Working around the clock, these engineers studied the behavior pattern of the tides. The data had to be accurate if the tide, salinity, and sedimentation conditions were to be duplicated on the working model.
The rise and fall of the tides and the accompanying tidal currents are created here by generating an inflow of water at this point. Water is drawn from this sump behind me and forced into the head bay of the model itself by means of this pump, which creates a flow of some 9,000 gallons a minute. Flow from this machinery is on a time schedule which is the same as the time schedule of the tides themselves. In the model itself, the tides rise and fall and act just as the tides would out in the bay itself, where they are governed and dictated by the gravitational pull of the moon upon the Earth's surface. The water here now is tap water, it's fresh water, but when the model is in actual operation, salt will be added in a proportion of 16 tons to 118,000 gallons of water, and this will bring it to the actual salinity of the bay itself. I'd like to have you meet now Colonel John S. Harnett, the district engineer for San Francisco. Colonel Harnett, as we understand it, the bay and its surrounding territory is recreated here to an exactitude as far as inches and miles are concerned. What about the factor of time? Is that also to scale?
Yes, it is, Bob. The time scale in the model is 1 to 100, or in other words, 1 hour on the model of testing is equivalent to 100 hours in nature.
That would indicate a tremendous saving in time. You should be able to amass quite a huge amount of data in a short time as a result.
Yes, we can, Bob, but however, the real significance, as far as the model is concerned, is that we can evaluate and determine from an engineering viewpoint the probable effects of the various plans and proposals which we will examine a long time prior to actual construction and the necessity to expend any large sums of money.
Here at the Sacramento River end of the model, another pump sends fresh water down the river channel in exact coordination with the inrush of the salt tide from the bay. Here we add coloring matter so that we can demonstrate this clash of nature as the salt tide meets the fresh water flowing down to meet the saltwater intrusion. And the purpose of this study is to determine just how far the salt water can force its way up the river channel and the subsequent danger to adjacent farmlands from the brine. In the dry summer season, when the water is low, additional water is released from the Shasta Dam far in the north to give a larger flow of fresh water to hold the salt water at bay. Actually, in many estuary situations, the fresh water tends to ride up over the salt water in the form of a wedge, which will require a great deal more fresh water to hold the salt back. In this particular instance, we're very lucky because a tidal situation provides a thorough mixing which makes a more positive barrier and requires less fresh water to do the job.
Working models are the tools with which an engineer can assail a problem that cannot be evaluated by known theories or measured and gauged due to the enormity of the project. Models provide probable designs, confirming the adequacy and feasibility of a plan. Even though the models in many cases do not appear as an exact replica of the project being studied, they are constructed to obey the same physical laws that the prototype abides by.
And I think, too, that in the story that we've seen tonight of man's attempt to cooperate with and understand nature, we learned a little more about the basic success story of our entire civilization. Thank you, General Cassidy.
Thank you, Mr. Day.